Hi, welcome back. Now in this video, we'll be going through some PSLE questions, and we're going to cover mainly experimental setup kind of questions as well as questions on magnets. Let's get started. The questions that will be discussed will come from the 2006 to 2010 PSLE papers. Let's start with this question. A certain type of green fruit gives off a gas P. When this fruit is stored together with some fresh flowers in a container, gas P causes the flowers to wither quickly. Without gas P, the flowers would normally remain fresh for a longer time. Lisa carried out an experiment to find out if a substance X can remove gas P. She used two similar plastic boxes, A and B, with lids. In box A, she placed some fresh flowers, the green fruits, and substance X, as shown below. The lid is of course there to make sure that there is no exchanges of gases, and that the gas that's produced by the fruit, gas P that's produced inside, remains inside and does not escape. That is the purpose of having the lid. Now, in order to carry out this experiment correctly, an experiment's aim is to find out whether X can remove gas P. Which one of the following should Lisa place in box B? Now, to make it simpler for us to understand, I drew up this table. Now, what you can see is that in box A, we have the flowers, the green fruit, the substance X here that's supposed to absorb the gas that is given off by the fruit. Now, does X really absorb this gas? I'm not sure, but if it does, then the flowers will stay fresh for a longer time. But how do I know if it really stays fresh for a longer time? I will know if I can compare with something else. What if my other box B here is something I can compare with flowers as well, with a green fruit, the similar kind of green fruit, similar size, that also give us gas P, but there is no substance X here to absorb the gas that's given off. If this really absorbs gas P, the flowers in box A will definitely stay fresher for a longer time than the flowers in box B. Therefore, this is the correct setup that we need. We need to have the flowers and the fruit. So let's go back to the aim. If this is the aim, therefore, this would be your change variable. Change variable means it is present here, it is absent here. So understanding this will tell us the answer is number 2. Let's go to the next question. This question is about the topic that you learn in primary 3 on diversity of living things. And one thing living things do is that they respond to changes in their environment. So you notice here that there are 3 petri dishes with different kinds of environments. So let's go through the question. Alvin carried out an experiment to study the preferred environments of worms. 20 worms were put in the middle of dish A. After 10 minutes, the number of worms in each dish was counted. So how it started off was they have the 20 worms in the middle of each dish. Alright? And then they observe how these worms, which are living things, respond to their immediate environment. And the experiment was repeated with dish B and C using the same number of similar worms and of course placed in the same manner in the middle of each of the dish. And it's very clear that if you look at dish A, the worms prefer a damp environment. Okay, we know worms prefer damp environment. How about dish B? Well, they prefer a dark environment. Not as drastically as in preferring damp. Comparing between a wetter place or darker place, well, the worm seems to prefer wetter place to darker place. How about this? And we're supposed to now predict which of the following shows the likely number of worms in each section of dish C, by knowing their preference for different kinds of environments. What do you think is the answer? To make it slightly easier for us to understand this, I presented this as a little table. So what I've done is this. We know that most of them like to go to the damp place, alright? 15. And they like to go to the dark place as well. The fewest won't go to the dry place, alright? Comparing between a place that's bright and a place that's dry, they don't like both, but they seem to dislike the dry places more than the bright places. So there will be fewer here compared to this. Now, having this in mind, how should the distribution look like? So here it talks about being damp and dark, damp and light, dry and light, dry and dark. So let's use mine now. So I think that in this case here, what is very clear is that the places that they like the most would be this, the damp and dark places, because that's where we see them congregating more in dish A and B. And the places that they like the least will be the places that are dry and bright. And dry and bright place is this quadrant here, in this part. Let's see if this allows us to get the answer. The most number here, the least number here. Let's take a look. And it seems that the most number 9 is here, the least number 1 is here. So the answer for this is 1. Now, of course, when you check your work, if there is an error, it could be my marking because I'm not perfect. Just come back to me in school and show your work to me and I will adjust it. Alright? Let's go to the next question now. So now we are at question 20. Nick learned in his science lesson that bacteria present in the air cause food to turn bad. He also learns that when food is exposed to more air, the food turns bad faster. So the information is given to you that bacteria causes food to turn bad, and when there is more air, because bacteria is in the air, more air means more bacteria means food turns bad faster. Makes sense? Nick carried out an experiment using a packet of milk and the 3 setups shown. So this is the food that's supposed to turn bad. In setup A, the milk is exposed to the air. In setup B, it is exposed to some air, but because it is stopped here, so no fresh air can come in. So the amount of bacteria is restricted to whatever is in the little space of air here. In setup C, it is stopped, but it's stopped with a loosely fitted cotton wool. And that means that air can pass through this. Not as easily as in setup A, but air can still pass through this, so new bacteria can still come in. He put the same amount of milk in 3 test tubes and left the test tube at room temperature. For each setup, he recorded the number of hours for the milk to first turn bad. Which of the following shows the correct order in which the milk in the setup turned bad, starting from the shortest time to the longest time? Meaning that the food turns bad the fastest. So since this milk in setup A is exposed to the most amount of bacteria, the milk in setup A should turn bad the shortest time. So A must be first. So now we're down to just 1 and 2. And then the one that's exposed to the least amount of bacteria is in setup B, because the amount of bacteria is only confined to the amount of air present here. So B will take the longest time. The milk in B will take the longest time to turn bad, and that will be here. So the answer for this question 20 is 2. Let's go to the next question now. This is question 21. In wanted to investigate the effect of temperature on the growth of plants. So this is something like her aim. She wants to find out how temperature affects the growth of plants. Which dishes should she compare in order to draw a correct conclusion? Now, since she wants to investigate the effect of temperature, temperature is the change variable and that has to change. Everything else must be constant. So if we can't be comparing A and B nor C and D because the temperature is the same. So A and B, this option is out. So right now we can compare either A with C, A with D because different temperatures, or B with C, B with D. And when they're placed too close together, well, there will be competition for things such as the amount of water and the minerals present inside, or whatever soil was given to the plants. And as they grow taller, well, the taller ones will block the light of the shorter plants and they'll compete for light. They compete for things like water and light and minerals. Therefore, this is not a fair test because the plants here are spaced too closely together to compete for all of this. Let's look at A and D. A and D, different temperature, great, but the way the plants are spaced out again looks very different. So I cannot use this because here there are two change variables, temperature and how far the plants are spaced out. Let's look at B and C. B and C, okay, they're spaced out in the same way and they are at different temperatures. So this is a change variable and this is constant. So this looks correct. Let's double check by checking the last one. B and D, different temperature, but the way the plants are being spaced out, these two sections here are crowded, whereas this is all evenly spaced out. So two change variable, no, this is wrong. Let's go to the next question, which is question 24. Which of the following needs to be present for bread to turn moldy? Now, this is, again, remember we're talking about the topic of diversity of living things, and one of the things that we learned in that topic is living things need air, food, and water. So if it turns moldy, means that the mold is the thing that's growing on it. This is the living thing that we're talking about in this question. Not the bread, but the mold. And for a mold to grow, of course, it needs things like all of us need. It needs food. Now, food is present. How about air? And in air, because we're in P6, we are not looking at air as in all the gases. Specifically, they will need oxygen to respire. They will need water as well. And mold is not a plant, so of course, they do not need light. They do not need carbon dioxide. In fact, they give out carbon dioxide as they respire. So A and C will be needed. Of course, food is needed, but it's already given. So answer is 3, A and C. And for the last life science question, let's go to question 26. Nadia put a plant inside a black box with a hole. She placed the setup in a well-lit place and watered the plant daily. Notice that this is a sealed-up box with a tiny hole at one end of the box, one side of the box. Now, in science question, when we talk about black box, it always refers to a container that does not allow light to pass through. I know this is not true all the time, alright? Depends on the kind of material, but this is the nature of our science question. If it is a black box and the material, like for example wood or cardboard or paper, is not given, we assume that light cannot pass through it. Of course, light can pass through a hole. This is just air, so light can pass through it. Of course, plant being a living thing will respond to light because it will grow towards it. It needs light to photosynthesize, to make food, right? The chlorophyll in the chloroplast to trap light. So as it grew, the stem bends towards the hole. If you chose to, then you did not understand the concept of plants responding to the light in the environment because plants need light to make food. Alright, always go back to the concept. Don't just look at, it seems to be bending downwards. It's actually bending towards the hole, not bending downwards. Now, water made the top part of the plant heavier. Again, it's not linked to the concept. Remember, the concept here is about living thing responding to changes. And this particular living thing is a plant, it responds to light. More water vapor, again, not linked to that concept. Clearly, this is a concept that's linked to this. Because light is outside and the plant craves for light, it will grow towards the light source. Now let's go on to the physical science portion of today's lesson. We will begin with question 5. 5 bar magnets with their ends marked A to J can be arranged as shown below. Which of the following diagrams show a possible arrangement of 2 of the magnets? Now this is a very typical question, as in there are not many ways you can test this. So once you know the technique to solving this is a Santa Claus question, which means to me, you're getting 3 marks for this. Right, so what we do is we always just assume the poles. Right, not given the pole, let's assume. We know that, let's say call it north and south. We know that unlike poles attract, so this must be a north, then south. Unlike poles attract, so this must be a north, then south. Unlike poles attract, if this is south, this must be north, then this is south. Unlike poles attract each other, if this is south, this must be a north-facing pole. Alright, now the answer here would be 1. You know, this is B and I. What is B? B is a south-facing pole and I is a north-facing pole. So this is a possible arrangement. They will attract each other. All the rest does not work. D and J. D is south-facing pole. J is south-facing pole too. Like poles will repel. So this is not possible. G and C. G is a north-facing pole. C is a north-facing pole. Like poles repel. This is not possible. B and F. B is south-facing pole. F is a south-facing pole. Once again, like poles repel each other. This is not possible. Answer is 1. Let's go to the next one. Let's go to question 8. Gopal wanted to study how the volume of a substance S is related to its mass. He took a certain amount of substance S and measured its mass and volume. Which of the following should Gopal do to ensure that the experiment is carried out correctly? Now, of course, for those who are quite observant, you will notice that shouldn't this be under the concept of cycles, because it talks about matter, it talks about mass and volume. That is possible, but I grouped it under this particular set of work because of the topic and theme of experimental setup, doing fair tests and all that. So let's take a look at it from that angle. Now, so to help us understand this, I drew a picture. So he wants to understand, right, how the volume of S is related to the mass of S. So he's trying to think, does it mean that when the volume of S increase, does the mass increase? When the volume of S decrease, does its mass also decrease? So how should he carry out the experiment correctly? So he should measure the mass of S, which is using things like a digital balance, using different amounts of S. Yeah, I use a certain amount of S here. Let's say this is 100 ml, 100 ml, but here we look at how many grams, and here maybe use 10 ml, less volume, and same amount 10 ml here, and find out what's the mass. So A definitely must be part of the answer. Let's take a look at B. Repeat the experiment using different substances. And that is kind of weird because the question is how the volume of S is related to its mass. We only want to talk about S, not about other substances. So anything with B is wrong. So anything with B is wrong, so wrong, wrong. Okay, now we're left with just C. Keep the temperature of S the same. And that is true because we learned in the topic of heat energy that matter expands when it gains heat. So if you talk about measuring volume, alright, if matter expands, it will have a greater volume. So to make this a fair experiment, right, and we must keep all the other variables constant except for the different amounts of S that you're using. Therefore, the temperature must be kept the same when you're doing it in this way and this way. Alright, you can't be doing this at room temperature, then this one you put it over a hot flame. Then the volume may change. And the heat may even cause the substance to evaporate much faster. So therefore, I must keep the temperature the same. So A and C. So question 8 answer is 2. Next, let's go to question 14. Similar balls of different materials P, Q, and R were placed in liquids X and Y. The balls stayed at the position as shown below. So Q sank to the bottom in this liquid, whereas P floats in this liquid X. The P that floated in liquid X actually sank in liquid Y. I'm going to color it. I think it's helpful to do this kind of thing on your PSLE paper. Alright, the examiners will not look at it. You just do it because it helps you, not because you want to decorate it. So this red color ball, which is the P ball P or material P, will sink, but R will float. So what happens when, and these two liquids don't mix? In your experience, things that don't mix, liquids that don't mix will be things like water and oil. Now, liquid X and Y do not mix together, so they will always appear in two tiers like this. When they were poured into a container, liquid Y floated on top of liquid X, alright, as shown in all the 4 diagrams here. If similar balls of P, Q, and R were added to the container, which of the following diagrams will show their correct position? So let's be very straightforward and look at the bottom part. This liquid X. Which material sank in liquid X? Q, right? Only Q sank in liquid X. So I'll check out Q first. Q must be at the bottom. So I'm going to use purple to represent Q. So Q must be at the bottom of liquid X. So this is possible. This is possible. This is possible. The fourth one here is not possible because it's not sinking. So option 4 is wrong because Q somehow is floating. Alright, I'm down to 3 options. Let's take a look at something else. I know that R floated on top of Y. Let's check R right now. Okay, I'm going to use a different colored one to represent R. R floats on top of Y. So I have R here. I have R here. Okay, how come R sank? It should be on top of Y. So now option 1 is wrong. I'm down to 2 options. Now let's check for the position of P. P was floating in liquid X. It wasn't at the bottom. Here, it shows P at the bottom of liquid X. This is wrong. So you're left with option 3, where P was floating. So 3 is the answer for question 14. Now let's go to the next one, which is question 18. Rajan was given a beaker containing 3 powders X, Y, and Z mixed together. These powders cannot be dissolved in water. The properties of the 3 powders are given in the table below. A, B, C. Dissolve means it mixes completely in water. Right, it's like you pouring some kind of powdered drink like sugar. Maybe you put sugar inside water and you stir it. After a while, the sugar kind of disappears into the water. That is called dissolve. And you'll learn that more when you go to secondary school. So let's look at this table. So there are 3 powders, alright, and they do not dissolve in water. So you put them in water, they will stay in water. And you're told that there could be different properties you can use to separate them. Because this Rajan, a very strange fella, he mixed them and then he wants to separate them. Okay, so maybe it's quite free, huh? What property or properties should Rajan use in order to separate the 3 powders quickly? Well, he was looking at magnetic property of these materials, which means whether they can be attracted to a magnet or not. You look at things like conductivity, electrical conductivity, does it conduct electricity or not? And things about buoyancy, which is whether it can float or sink in water. So which are the properties you can use to quickly separate this? So let's take a look at property C. I like the idea about floating because things that don't float will sink. So for example, let's say he pours X, Y, and Z into some water. Now we know that X and Z will sink. So let me write down X will sink to the bottom, Z will sink to the bottom, and Y, hooray, will float. So Y is on top of the water. So just by pouring the 3 powders inside some water, he will get Y that's floating, and he can scoop this out. So he has separated Y. Now leaving X and Z. He just need to pour the water away. Alright, now let's see, how can we separate X and Z? Let's say now he has a container, he placed all the dried X and all the dried Z together. So how can we separate this now? Let's take a look at property A. If he place a magnet over them, alright, powder Z will be attracted to the magnet because it is a magnetic material. Whereas powder X is not. X will remain and just stay inside the container, and X will just stay inside. And that's how you can separate them using first property C, then followed by property A. So the answer is 3. Property A and C. Let's go to the next question, question 21. Another question that tests the understanding about the properties of materials, whether they can float or sink. Now, objects A, B, C, and D are made of different materials but of the same shape and size. So same shape and size but different materials. Therefore, their mass will also be different because they are different materials. A 100-gram mass was glued to each object. Each object was placed on the surface of the liquid in the tank. The objects were at different positions as shown below. So this is how it is like. Okay, so very clearly, C will sink. And the other 3 floats, but they float to different degree. Alright, this floats the most, this float the least. Of course, this doesn't float at all, it just sinks. Now, which of the following shows the correct order of the objects, starting from the smallest mass to the greatest mass? Now, the assumption here is that objects with more mass will sink. Now, you haven't learned the idea about density yet, so I will not talk about density. But if you're interested, you can go and read up more about density and the formula to understand this better. But you don't need that to solve this. Just assume that if the object has more mass, alright, compared to another object of the same size, very important, huh? Same size means same volume. So object of, let's say, this object and this object. This one has more mass, 100 grams. This one less mass, 50 grams. This will sink more than this, right? Because even if their volume is the same. So with that assumption in our mind, more mass but same size will sink, less mass will float. Then of course, the one with the most mass must be C. So greatest mass is on the right hand side because we want us to arrange from smallest to greatest. So C will be on the right hand side. That leaves us with only option 1 and 2. So 3 and 4 will be out. And the one with the least mass must be the one that floats the most. So clearly you can see, okay, we have B here, float the most. So after B, which one floats the most? This one. It is less, right? It's above the water more than this, right? It floats much higher than this. So D will be after B. So the answer is 2 for question 21. We go to the next one now, question 40. Diagram 1 below shows a ring magnet lowered onto a tray of steel pins. Diagram 2 shows the bottom view of the magnet. So steel pins, and you learn in primary 4, there are 2 kind of materials that are magnetic, iron and steel. So this is to tell you, and when you link to an object called magnet, you know for sure the idea of steel pin here is to provide you with some magnetic material that can be attracted to the ring magnet. Then you place the bottom of the ring magnet over this. So which one of the following most likely shows the position, shows the number of pins attracted to the bottom of the magnet at positions A, B, and C? Now, you would have played with a ring magnet before. So unlike a bar magnet, you're very clear when you talk about north and south pole. You know that at one end will be the north pole, right? One end. Whereas the other end will be the south facing pole. But what about a ring magnet? Where is the so-called north and the south? It goes one round. There's that no end, right? It's just keep on going round and round and round. For a ring magnet, the north and south poles actually on the top and bottom. So if I have to draw it this way for you to see, you will shade the bottom part of this red to represent one of the poles. So the whole bottom will be one pole, and the whole top will be a different pole. Okay? So if you look at it from the side, it will look something like this. Something like a north on top and south below. If that is the case, if that's the understanding, then you should see that the number of pins attracted to the bottom will be the same. So therefore the answer here is number 4. Now stay on more to the end. I'll do a bonus experiment to show you this. Now let's go to the last question. Right, so the answer for this is number 4. The last question is question 44. Let's go to the last question now. Rachel set up 4 experiments P, Q, R, and S using water in containers made of the same material. The table below shows the different conditions at the start of each experiment. Room temperature, exposed surface area, volume of water. Very clearly, it is under the topic of cycle, about rate of evaporation. But since I group it here, that means the purpose is to look at experimental setup. It's not so much about water cycle and stuff. Okay, so I'm assuming that you know the 3 conditions for rate of that affects the rate of evaporation. And here we're looking at experimental setup only. Now, Rachel wanted to investigate how the rate of evaporation of water was affected by the exposed surface area. Alright, so therefore this is the change variable. So this must be different for the 2 setups that she chooses. So let's ignore everything else. Let's use this one idea. Exposed surface area must be different. Look at P and Q. Is different. Okay, this is possible. R and P. This is the same, right? 50 and 50. This is not possible. One option is out. Q and S. Right? The exposed surface area is different. This is a possible answer. S and P, these 2 are the same at 50 square centimeter, so this is out. Okay, so using just this one idea about understanding the change variable, we can rule out 2 answers. Let's take a look at something else. The next idea you must know about doing a fair experiment is all the other variables must remain the same. So look at P and Q. These are different, alright, which is good. We want them to be different. Everything else must be the same. All the other variables, like the temperature, must be the same. Oops, they are different. So P and Q cannot be the answer anymore. To be very sure, let's check Q and S. Q and S, yes, this is different like what we want, the exposed surface area. Everything else, like room temperature, must be the same. Yes, they're the same at 25 degrees Celsius. The amount of water must be the same. Alright, same. Great. So, confirm Q and S is the answer. Good job for staying all the way to the end. Now for the promised bonus activity. About the ring magnet, I did tell you before that just now I drew a diagram, right? This is the ring magnet. Look at my hand, that is really huge. So I was telling you earlier on that the top part represents one face. I'm not sure if it's north or south facing. And the other end will be either north or south facing. Alright, and if that is true, that every one of these is a single one pole. So if I were to place magnets on this, I should see the attraction of only one of the pole. So I have a magnet here, alright, and if I place it here, okay, I can actually feel the the attraction. So the blue part is the south facing pole. It is attracted to this face of the magnet, right? South facing pole. Now, if that is true, if I place more of this magnet on this, only the south facing pole will be attracted to this top, which I assume right now is the north, right? No matter I put it here or here or here. It's better if I just use more, right? South facing pole, south facing pole, the south facing pole of the bar magnet, another one, and another one. So the other side must be the north facing pole. So must be the other pole. Let's take a look. If the south facing pole was attracted to the other side just now, means the other side was the north pole. So this must be the south pole. Let's check. South and north, unlike poles attract. Okay, so thanks for staying on. Take care. I'll see you in the next video. Goodbye.